Hello dear students, welcome back to the second PUC online classes. Dear students, in this class I am going to discuss about the relation between force of attraction or repulsion between the 2 point charges in an air between the medium and principle of superposition for Coulomb forces. In the previous video lecture already I discussed the concept of Coulomb's law and Coulomb's law in vector form. We know that the force of attraction or repulsion between the 2 point charges at rest, that is directly proportional to product of their magnitude of the 2 point charges and inversely proportional to square of distance between them, and the force acts along the line joining between them. According to the Coulomb's law of forces here, F in air means force in the air medium, electric force between the two charges. Now I consider here the Q1 and Q2. This is Q1 and this is Q2. Q1 and Q2 separated by small distance r in an air. Separated by small distance r in an air, that is electric force between the two charges Q1 and Q2 separated by distance r in an air or vacuum, that is given by F air is equal to 1 divided by 4 5 epsilon naught. 1 divided by 4 pi epsilon naught Q1 into Q2 divided by r square, which is the expression for electric force between the two charges Q1 and Q2 separated by a small distance or in air or vacuum. But now I place the electric force between the same charges. Electric force between the same charges. ಇಲ್ಲಿರ್ತಕ್ಕಂತಹ ಚಾರ್ಜ್ಗಳನ್ನ again now I consider Q1 and Q2 are the 2 point charges. These 2 point charges separated by a small distance are electric force between the same charges kept at the same distance. ಇಲ್ಲಿ r equal to 1 meter ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದೀವಿ ಅಂದ್ರೆ ಇಲ್ಲಿ ಕೂಡ r equal to ಏನಾಗಿರಬೇಕು 1 meter. But in a medium of dielectric constant, ಅಲ್ಲಿ ಏರಿತ್ತು, ಇಲ್ಲಿ in a medium of dielectric constant epsilon r. In a medium of dielectric constant epsilon r. This is called permittivity of free space or relative permittivity. ಇದನ್ನ ಏನಂತ ಕರೀತೀವಿ ನಾವು epsilon or relative permittivity. Epsilon naught means permittivity of free space. Epsilon r means relative permittivity. Here now I consider the electric force between the same charges kept at the same distance in a medium of dielectric constant epsilon r. Therefore, for the dielectric constant epsilon r, F medium equal to 1 divided by F medium is equal to 1 divided by 4 5 epsilon naught into epsilon r. ಇಲ್ಲಿ only epsilon naught ಅಂತ ಯೂಸ್ ಮಾಡಿದೀವಿ because in an air the dielectric constant epsilon r equal to value is 1. Epsilon r equal to value is 1. But for the medium, F medium equal to 1 divided by 4 pi epsilon into epsilon r. Now Q1 into Q2 divided by r square. This is equation number 2. The force, electrostatic force between the 2 point charges in the air medium and the electrostatic force between the 2 point charges in a medium other than air and vacuum. Now the ratio of the force between the 2 point charges in the air to the force between 2 point charges in the medium, dividing equation 1 by 2. Dividing equation 1 by 2. When you divide the equation 1 by 2, we get F air divided by F medium. F air divided by F medium. ಇಲ್ಲಿ ಉಳಿದಿರತಕ್ಕಂಥ ಎಲ್ಲ ವ್ಯಾಲ್ಯೂ ಕೂಡ ನಾವು ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿದಾಗ ನಮಗೆ ಉಳಿತಕ್ಕಂಥ ವ್ಯಾಲ್ಯೂ ಓನ್ಲಿ epsilon r. Epsilon r is equal to F air divided by F medium, or epsilon r, this is equal to constant K is equal to F air divided by F medium. F air divided by F medium. Here this is called dielectric constant. This is called dielectric constant anta ಕರೀತೀವಿ ನಾವು. This is called dielectric constant or This is also called relative permittivity. This is also called relative permittivity. Relative permittivity. Only epsilon naught means permittivity of free space ಅಂತ ಹೇಳ್ತೀವಿ. Epsilon naught ಅಂತ ಯಾವುದಕ್ಕೆ ಹೇಳ್ತೀವಿ ನಾವು? Permittivity of free space. And epsilon or k is equal to, this is permittivity of the medium. Permittivity of the medium, epsilon naught and epsilon r. Here the force between, or electrostatic force between two charges q1 and q2, they are separated by a small distance or in an air or vacuum. That is equation number 1. And the electric force between the same charges kept in the same distance in a medium of dielectric constant epsilon r. That is equation number 2. Therefore we get, when we divide the equation 1 and 2, the ratio of force between the two charges in an air to the ratio of force between 2 point charges in the medium is called, that is relative permittivity. This is called a relative permittivity. The relative permittivity of a medium, it is defined as the ratio of electrostatic force between them. The ratio of electrostatic force between the 2 point charges separated by a distance in air or vacuum to that the same two charges separated by same distance in a medium. This is called relative permittivity. ಯಾವ ರೀತಿ ನಾವು ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ relative permittivity ಅನ್ನು? Or this is also called dielectric constant. It is defined as the ratio of electrostatic force between the two charges separated by a certain distance in a air to the between or to the same two charges separated by the same distance in a medium. This is called relative permittivity or dielectric constant. Hence it proved epsilon r is equal to k in equal to f air divided by f medium. The ratio of electrostatic force between the two charges separated by a certain distance in air or vacuum to the same two charges separated by the same distance in a medium. ಎರಡು ವ್ಯಾಲ್ಯೂದು ರೇಷಿಯೋವನ್ನು ತೆಗೆದಾಗ ಬರ್ತಕ್ಕಂಥ ಆನ್ಸರ್ಗೆ ನಾವೇನಂತ ಕರಿತೀವಿ? That is called relative permittivity of the medium or dielectric constant. Here this dielectric constant, it is different for different material. Now we will see about that value. The dielectric constant epsilon r, this is relative permittivity of the medium or dielectric constant. For air or vacuum, r is equal to 1. Actually, in general formula of the Coulomb's law is F equal to 1 divided by 4 pi epsilon naught into epsilon r into q1 into q2 divided by r square. F equal to 1 by 4 pi epsilon naught into epsilon r q1 q2 divided by r square. In air anta now consider ಮಾಡಿದಾಗ electrostatic force between the 2 point charges in an air is, that is 1 divided by 4 5 epsilon naught into q1 into q2 divided by r square, because here the epsilon r value, it is a constant. Epsilon r is equal to 1. And the relative permittivity or the dielectric constant for the paper is 3.5, and for the glass is it is 5, and for the water is 80, and for the metal is it is infinity. Remember all these values. Here the relative permittivity or dielectric constant, it is different for different materials. Okay, and it has a certain limitations. Coulomb's law in electrostatic in general formula is 1 divided by 4 5 epsilon naught into epsilon r q1 q2 divided by r square. It is in general formula. It is in general formula. But for the 2 point charges, they are placed in the air or vacuum. That for that purpose we get this equation: force, electrostatic force between the two charges in the air or vacuum is 1 divided by 4 pi epsilon naught q1 into q2 divided by r square. But it is applicable only when the 2 point charges are at rest. Now I consider here the q1 and q2. q1 and q2, these are the 2 point charges. These 2 point charges separated by a small distance in an air or vacuum. Separated by a small distance in an air or vacuum for this equation only. But here Coulomb's law, it is applied to only when the charges are at rest, because ಇಲ್ಲಿ ನಾವು ಟಾಪಿಕ್ ಸ್ಟಡಿ ಮಾಡ್ತಕ್ಕಂಥದ್ದು ಓನ್ಲಿ ಎಲೆಕ್ಟ್ರೋಸ್ಟ್ಯಾಟಿಕ್ಸ್ ಇದೆ. ಎಲೆಕ್ಟ್ರೋಸ್ಟ್ಯಾಟಿಕ್ ಮೀನ್ಸ್ ಇಟ್ ಈಸ್ ದ ಬ್ರಾಂಚ್ ಆಫ್ ಫಿಸಿಕ್ಸ್ ವಿಚ್ ಡೀಲ್ಸ್ ವಿತ್ ದ ಸ್ಟಡಿ ಆಫ್ ದ ಚಾರ್ಜಸ್ ಆರ್ ಅಟ್ ರೆಸ್ಟ್. ಚಾರ್ಜ್ ರೆಸ್ಟ್ ಇರೋದ್ರಿಂದ ಇಟ್ ಈಸ್ ಅಪ್ಲಿಕೇಬಲ್ ಓನ್ಲಿ ವೆನ್ ದ ಚಾರ್ಜಸ್ ಆರ್ ಅಟ್ ರೆಸ್ಟ್ ಓನ್ಲಿ ಆ್ಯಂಡ್ ಇಟ್ ಡಸ್ ನಾಟ್ ಅಪ್ಲಿಕೇಬಲ್ ಟು ಚಾರ್ಜಸ್ ಆರ್ ಇನ್ ಮೋಷನ್. ಇದು ಫಸ್ಟ್ ಲಿಮಿಟೇಷನ್. ವಾಟ್ ಆರ್ ದ ಲಿಮಿಟೇಷನ್ಸ್ ಆಫ್ Coulomb's law? Coulomb's law is applied only when the charge is at rest. Apply to charges at rest only. If the charges are in motion, the Coulomb's law ನಾವು apply ಮಾಡಕ್ಕೆ possibility ಇಲ್ಲ. This is the first limitation. The Coulomb's law is applied to charges when they are rest only. If the charges are in motion, here Coulomb's law ನಾವು apply ಮಾಡಕ್ಕೆ possibility ಇಲ್ಲ. And the second condition, Coulomb's law in electrostatic is not values if R is less than 10 to the power of minus 15 meter. ಹಂಗಂದ್ರೆ ಏನಿದು ಲೆಸ್ ದನ್ 10 to the power of minus 15 meter? Here the radius of the nucleus value is, you know that concept of matter. The atom consists of proton, neutron and electron. All the electrons are revolving around the nucleus in a circular orbit. This is called nucleus. Nucleus contains protons and neutrons. The protons and neutrons together called nucleus. The size of the nucleus, it is in the order of 10 to the power of minus 15 meter. Size of the nucleus, it is in the order of 10 to the power of minus 15 meter. That's why the Coulomb's law in electrostatics is not valid if R is less than 10 to the power of minus 15 meter. ಇಲ್ಲಿ ಯಾವ ಚಾರ್ಜನ್ನು ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿರ್ತೀವಿ ಆ ಚಾರ್ಜದು, ಹೌದಾ, ಇಲ್ಲಿ Q1 and Q2 ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿವಿ. ಯಾವುದನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿವಿ? ಹಿಯರ್ ಇಫ್ ದಿಸ್ ಸೈಜ್ ಈಸ್ ಆರ್ ಈಸ್ ದ ರೇಡಿಯಸ್ ಆಫ್ ದಟ್ ಚಾರ್ಜ್ ಈಸ್, ಇಫ್ ಆರ್ ಈಸ್ ಲೆಸ್ ದೆನ್ 10 to the power of minus 15 meter, ಲೆಸ್ ದೆನ್ 10 to the power of minus 15 meter ಇತ್ತು ಅಂತಂದ್ರೆ ನಾವು ಇದನ್ನು ಅಪ್ಲಿಕೇಬಲ್ ಮಾಡೋಕ್ಕೆ ಪಾಸಿಬಿಲಿಟಿ ಇಲ್ಲ. ದೀಸ್ ಆರ್ ದ ಟೂ ಲಿಮಿಟೇಷನ್ಸ್ ಆಫ್ Coulomb's law. ಫಸ್ಟ್ ಒನ್ ಈಸ್ Coulomb's law, it is applied to charges at rest only, and Coulomb's law in electrostatics, it is not valid if R is less than 10 to the power of minus 15 meter. Okay, this is about Coulomb's law and the ratio of electrostatic force between the two charges in a air to the two charges in a medium and the limitations of Coulomb's law. ಹಾಗಾದ್ರೆ ಈ Coulomb's law ಅನ್ನು ನಾವು ಮಲ್ಟಿಪಲ್ ಚಾರ್ಜಸ್ ಇದ್ದಾಗ ಯಾವ ರೀತಿ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ? ಇಲ್ಲಿ ಓನ್ಲಿ 2 ಚಾರ್ಜಸ್ ಎಂಬತಕ್ಕಂಥ ಕಾನ್ಸೆಪ್ಟನ್ನು ನಾವು ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ. ಓನ್ಲಿ 2 ಚಾರ್ಜಸ್. ಬಟ್ ಮಲ್ಟಿಪಲ್ ಚಾರ್ಜಸ್ ಇತ್ತು ಅಂತಂದ್ರೆ ಅವಕ್ಕೊಂದು ಸರ್ಟೆನ್ ಲಾ, ಬೇರೆ ಲಾ ಇದೆ, ಅದಕ್ಕೆ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಸೂಪರ್ ಪೊಸಿಷನ್ ಪ್ರಿನ್ಸಿಪಲ್ ಫಾರ್ Coulomb ಫೋರ್ಸಸ್. ಸೂಪರ್ ಪೊಸಿಷನ್ ಪ್ರಿನ್ಸಿಪಲ್ ಫಾರ್ Coulomb ಫೋರ್ಸಸ್. ಮೋರ್ ದೆನ್ 2 ಚಾರ್ಜಸ್ ಇತ್ತು ಅಂದ್ರೆ ಅವಾಗ ನಾವೇನು ಮಾಡ್ತೀವಿ? ಸೂಪರ್ ಪೊಸಿಷನ್ ಪ್ರಿನ್ಸಿಪಲ್ ಫಾರ್ Coulomb ಫೋರ್ಸಸ್ ಆರ್ ಹಿಯರ್ the superposition principle for multiple charges ಅಂತ ಕೂಡ ಕರೀತೀವಿ. The electrostatic force on a point charge is due to the number of charges is given by the principle of superposition, and this principle is based on the property that the electric force between the two charges is, that is, unaffected by the presence of the other charges. Unaffected by the presence of other charges. Here the principle of superposition for the Coulomb's law, it states that, ಇದಕ್ಕೊಂದು ಸ್ಟೇಟ್ಮೆಂಟ್ ಇದೆ, principle of superposition for the Coulomb forces. It states that when a number of charges are present, when a number of charges are present, now I consider here when a number of charges are present ಅಂತ ಹೇಳ್ತೀವಿ. ಇಲ್ಲಿ ಬೇರೆ ಬೇರೆ ರೀತಿಯಾಗಿರ್ತಕ್ಕಂತಹ ಚಾರ್ಜ್ಗಳನ್ನ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ when a number of charges are present. Now I take, this is the charge Q1 and this is the charge Q2 and this is the charge Q3 and this is charge Qn or the charge Q4, so on up to the term charge Qn. When a number of charges are present, the total force on a given charge, the total force on a given charge, the force acting on the charge Q1 by Q2, force acting on the charge Q1 by Q3, force acting on the charge Q1 by Qn. The distance between these 2 point charges is, that is the unit vector 2 to 1, unit vector 2 to 1, and Q3 to Q1, the distance between Q3 to Q1 is, that is R cap 3 to 1, like that. The distance between Q1 to Qn is, that is unit vector R1n. According to the principle for Coulomb forces or superposition principle for Coulomb forces, it states that when a number of charges are present, the force on a given charge, ನಾನು ಇದನ್ನ given charge ಅನ್ನು ತಗೊಂಡಿ ಅಂತಂದ್ರೆ, the force on a given charge is equal to the vector sum of all the forces due to the remaining charges on the given charge. Remaining charges on the given charge. Here, the total force acting on the given charge. The total force acting on a given charge is equal to vector sum of the forces due to the charges on the given charge or remaining charges on the given charge. Here, the Q1, now I consider this is the for our reference. Q2 exerts the force on Q1, Q3 exerts the force on Q1, like that Q4 exerts the force on Q1, and Qn exerts the force on Q1. When a number of charges are present, the total force on a given charge, this is the total force. The total force on a given charge is equal to vector sum of the forces due to the remaining charges. Due to the remaining charges. Suppose if I consider this is the total force F. This is the total force F. And the Q2 acts the force on Q1. Now we get the value, that is force acting on the charge Q1 by Q3. F13 ಅಂತಂದ್ರೇನು, force acting on the charge Q1 by Q3, like that. Q2 ದಿಂದ Q1 ಮೇಲೆ force act ಆಗಿತ್ತು ಅಂದ್ರೆ, that is vector F12 ಅಂತ ಬರೀತೀವಿ. The force acting on the charge Q1 by Q2. The force acting on the charge Q1 by Q2 ಅನ್ನು ಏನಂತ ತಗೋತೀವಿ, F12, like that. The force acting on the charge Q1 due to this Qn. The force acting on the charge Q1 due to this Qn is, that is vector F1n. Vector F1n means force acting on the charge Q1 due to the nth charge. Due to the nth charge. It states that when the number of charges are present, the total force on a given charge is equal to the vector sum of the forces due to the remaining charges on the given charge. Here, according to the statement, this is the one system. It consists of n number of point charges like Q1, Q2, Q3, Q4, so on up to Qn terms in a vacuum, and whose position vectors with the origin O. This is the origin O with the position vectors, that is R1, R2, R3. These are the position vectors. According to the principle of superposition, when the number of charges are present, the total force on a given charge, that is vector F, the total force on a given charge is equal to vector sum of the forces due to the individual charges. Due to individual charges means vector F12 plus vector F13 plus vector F14, like this, vector F1n, that is F1, force acting on the charge Q1 is equal to force acting on the charge Q1 by Q2, force acting on the charge Q1 by Q3, force acting on the charge Q1 by Q4, so on up to force acting on the charge Q1 by Qn. According to the principle of superposition, the net force acting on the charge Q1 is, the net force acting on the charge Q1 is, that is F12 plus F13 plus F14 plus so on up to F1n. Here F12 means that is force on Q1 due to Q2. F13 means force on Q1 due to Q3. F14 means force on Q1 due to Q4, like that. F1n means force on Q1 due to Qn. Now, you know the formula actually. Force acting on the charge Q1 due to Q2. Force acting on the charge Q1 due to Q2 is equal to 1 divided by 4/5 epsilon naught Q1 into Q2 divided by R square into unit vector R12. ಯೂನಿಟ್ ವೆಕ್ಟರ್ r12 r ಸ್ಕ್ವೇರ್ 1 to 2 ಡಿಸ್ಟೆನ್ಸ್ ಇದು ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ ಇರ್ತಕ್ಕಂಥದ್ದು ಹೌದಾ. ದಿಸ್ ಈಸ್ ಇಕ್ವೇಶನ್ ನಂಬರ್ 1 ಅಂತ ತಗೋಬಹುದು. ದಿಸ್ ಈಸ್ ಫ್ರಮ್ ದ ವೆಕ್ಟರ್ ಫಾರ್ಮ್ ಆಫ್ ಕೂಲಮ್ಸ್ ಲಾ. Like that, force acting on the charge q1 due to q3, that is F13 is equal to 1 divided by 4 pi epsilon naught q1 into q3 divided by r square 13 into unit vector r13. This is equation number 2. Like that, the force acting on the charge q1 due to the nth charge is equal to 1 divided by 4 pi epsilon naught q1 into q1 divided by r square 1 into n into unit vector r1n. This is equation number 3. ಇಲ್ಲಿ ವೆಕ್ಟರ್ ಫಾರ್ಮ್ ಆಫ್ ಕೂಲಮ್ಸ್ ಲಾನೇ ಯೂಸ್ ಮಾಡ್ಕೋತೀವಿ, ಬಟ್ ದಿಸ್ ಈಸ್ ಫಾರ್ ಮಲ್ಟಿಪಲ್ ಚಾರ್ಜಸ್. This is for multiple charges. Now substitute equation 1, 2 and 3 in this equation. ಇಲ್ಲಿ in general equation ಇದೆ ಅದು. According to the principle of superposition, the net force acting on the charge q1 value ಅನ್ನು ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿದೆ. Net force acting on the charge q1, that is vector f1 is equal to ಎಲ್ಲ ವ್ಯಾಲ್ಯೂವನ್ನು ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿ. f12 ಅಂದ್ರೆ ವ್ಯಾಲ್ಯೂ ಏನಿದೆ 1 divided by 4 pi epsilon naught. ಇಲ್ಲಿ ನೋಡಿ ಇಕ್ವೇಶನ್ ನಂಬರ್ 1, ಇಕ್ವೇಶನ್ ನಂಬರ್ 2, ಇಕ್ವೇಶನ್ ನಂಬರ್ 3 ಮೂರರಲ್ಲಿ ಕೂಡ ಇದು ಕಾಮನ್ ವ್ಯಾಲ್ಯೂ ಇದೆ. ಟೇಕ್ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಔಟ್ಸೈಡ್. 1 divided by 4 pi epsilon naught ವ್ಯಾಲ್ಯೂವನ್ನು ಔಟ್ಸೈಡ್ ತಗೊಂಡಾಗ ಉಳಿದಿರತಕ್ಕಂಥ ವ್ಯಾಲ್ಯೂ ಏನು q1 into q2 divided by r square 1 to 2 into unit vector r12 plus. For this equation number 2, force acting on the charge q1 by q3 ಈ ವ್ಯಾಲ್ಯೂವನ್ನು ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಕ್ಕೆ ಹೋದಾಗ 1 by 4 pi epsilon naught ವ್ಯಾಲ್ಯೂ ಟೇಕ್ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಔಟ್ಸೈಡ್. ಉಳಿತಕ್ಕಂಥ ವ್ಯಾಲ್ಯೂ ಏನು q1 into q3 divided by r square 1 to 3 into unit vector r13. Unit vector r13. Like that, force acting on the charge q1 by q4 or q5 so on up to nth term, plus here we get q1 into qn divided by r square 1n into unit vector r1n into unit vector r1n. According to the principle of superposition, when a number of charges are present, the total force on a given charge that is equal to the vector sum of the forces due to the remaining charges on the given charge. According to the statement, the net force acting on the charge q1 is, that is vector f1 equal to vector f12 plus vector f13 plus vector f14 so on of tfn term. ಅಲ್ಲಿ ಒಂದೇ ಟರ್ಮ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಿದ್ವಿ ನಾವು ಕೂಲಮ್ಸ್ ಲಾದಲ್ಲಿ 1 2 2 1 ಅಂತ ಹೇಳಿ. ಅದೇ ರೀತಿಯಲ್ಲಿ ಮಲ್ಟಿಪಲ್ ಚಾರ್ಜಸ್ ಇದ್ದಾಗ ಸಪರೇಟ್ ಆಗಿ ಅವನ ವ್ಯಾಲ್ಯೂವನ್ನು ಬರ್ಕೊಂಡು ಎಲ್ಲ ವ್ಯಾಲ್ಯೂವನ್ನು ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದಾಗ ಯು ಗೆಟ್ ದ ಈಕ್ವೇಶನ್ ಲೈಕ್ ದಿಸ್. ಆರ್ ಇದನ್ನು ಇನ್ನೂ ನೀವು ಇನ್ ಜನರಲ್ ಆಗಿ ಬರೀಬೋದು ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ, ವೆಕ್ಟರ್ f1 is equal to ಇದು ಎಲ್ಲದರಲ್ಲಿ ಕಾಮನ್ ಇರತಕ್ಕಂಥ ವ್ಯಾಲ್ಯೂವನ್ನು ನೋಡ್ರಿ. ಹೌದಾ, q1 ಅಂತ ಕಾಮನ್ ವ್ಯಾಲ್ಯೂ ಇದೆ. therefore take that q1 value outside. q1 divided by 4 5 epsilon naught. q1 divided by 4 5 epsilon naught ಅಂದ್ರೆ ಉಳಿದಿರತಕ್ಕಂಥ ವ್ಯಾಲ್ಯೂವನ್ನು ಎಲ್ಲವೂ ಕೂಡ ನಾವು ಸಮ್ ಮಾಡಬಹುದು. ಸಮೇಷನ್ ಆಫ್ ಎಲ್ಲಿಂದ, ಹೌದಾ, i is equal to ಇಲ್ಲಿ 2 ಇದೆ, 3 4 so on up to nth term. i is equal to 2 to n term. i is equal to 2 to nth term. i is equal to 2 to nth term ಅಂತ ಉಳಿದಿರತಕ್ಕಂಥ ವ್ಯಾಲ್ಯೂ qi divided by r square 1i into unit vector r1i. Here f is equal to q1 divided by 4 pi epsilon naught sum of I equal to 2 to n. ಈ ಇಕ್ವೇಶನ್ ಅನ್ನ ರೆಡ್ಯೂಸ್ ಮಾಡಿದಾಗ ಇನ್ ಜನರಲ್ ಸಮೇಷನ್ ಅಪ್ಲೈ ಮಾಡಿದಾಗ I equal to 2 to n ಎಲ್ಲಿ I ಇರುತ್ತೋ ಅಲ್ಲಿ 2 ದಿಂದ nth ವರೆಗೆ ನಾವು ಇಲ್ಲಿ ಇಕ್ವೇಶನ್ ಅನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ಕೋಬಹುದು. ಇಲ್ಲಿ 2 ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ 2 ಆಗುತ್ತೆ, ಇಲ್ಲಿ 3 ಮಾಡಿದ್ರೆ ಇಲ್ಲಿಯೂ 3 ಆಗುತ್ತೆ, ಇಲ್ಲಿ ಕೂಡ 3, ಇಲ್ಲಿ 4 ಮಾಡಿದಾಗ ಇಲ್ಲಿ 4 ಆಗುತ್ತೆ, ಈ ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ 4 ಇರುತ್ತೆ, ಈ ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ ಕೂಡ ಏನಾಗುತ್ತೆ 4 ಆಗುತ್ತೆ. ಇಟ್ ಈಸ್ ಅ ಇನ್ ಜನರಲ್ ಫಾರ್ಮ್ which is the expression for superposition principle for Coulomb forces, or this is the force between the multiple charges. It gives the expression for the resultant force between the multiple charges. Here r12 that is distance of q2 from q1, r13 ಅಂತಂದ್ರೆ ಏನು, distance of q3 from q1, r14 means distance of q4 from q1. Like that, r1n means distance of qn from q1 or ಯೂನಿಟ್ ವೆಕ್ಟರ್ r21 ಅಂತ ಕರಿತೀವಿ or r21 or r12 ಅಂತ ಕೂಡ ಕರಿತೀವಿ. r12 ಅಂತ ತಗೊಂಡಿವಿ ಅಂದ್ರೆ this is r12, this is r13 and r1n. r1n means unit vector in the direction from q1 to q2. r13 means unit vector in the direction from q1 to q3, like that. r1n means this is unit vector in the direction from q1 to qn, which is the expression for ಯಾವ equation ಅಂತ ಕರಿತೀವಿ ಇದಕ್ಕೆ? expression for the resultant force between the multiple charges. resultant force between the multiple charges. And what are the limitations of Coulomb's law? Coulomb's law is it is applicable only for when the charges are at rest, and it does not applicable for the charges are in motion, and it is only valid up to the size of the charge is. It does not applicable for the less than the r is less than 10 to the power of minus 15 meter. Okay, thank you.